Hello and welcome to another video. In this video we're going to be going over the sum of square numbers. And so in this one you're given a non-negative integer c and you want to decide whether there's two integers a and b such that a squared plus b squared equals c. So in this first one that is the case, and the second one there's not. So the main thing to solve this problem is to note that c is this, so 2 to the 32. And so let's say we were looking for like what's the biggest value of a and b we can possibly have. So the biggest value of a and b we can have is actually root of c, because you would just have like a b root c and then b 0, right? And then you'd have like a squared plus 0 equals c, where a is root c. And so because c is limited to this, root c is 2 to the 16th. And 2 to the 16th is like 65,000, which is fine, which is like small enough to have things pass. So there's only, basically 65,000 numbers you can have. Like let's say c is 2 to 32. There's only 65,000 numbers that a and b can be. And then for each one of those, you can kind of figure out the other in O of 1, because let's say, for example, c is like some number, and a is some number. So we just give a value to a. So then we have a squared plus b squared equals c. We know c, we know this. So then we can just solve for b, which is c minus a squared, and we take the square root. And we could solve for this. We could solve for this guy, right? So for every single number in a, we can just solve for a b, and then we can try and see if both of these are whole numbers. Yeah, so basically we'd like try, we would always try a whole number for a, we would solve for b, and as long as b is a whole number, we can get the answer. So kind of like in this example, we could say like, okay, well, if we make a 1, so we get 1 squared plus b squared equals 5. So b squared equals 4. And b equals 2. And is 2 a whole number? Yes, it is. So then we have a solution. And for this, you're not going to be able to find any. That's basically how you do it. And there's kind of two solutions that I can think of that both work pretty well. I'll talk about one and then we'll code the other. So one is actually just get all of the numbers from 0 up until the biggest number that can be a square root of c. So let's say c is like 100. You would try, or so let's say c is like 101 or whatever. Then you would try like 0 to 11, let's say, or whatever. And you would get all of the numbers, so you just have all of these, so 0 to 11. And then you would start with a being the smallest and b being the biggest. And then you would calculate like, okay, for this case, what number do I get? So in this case, I'd get 121. And then if I'm looking for, let's say like 105 or something, you just say like, okay, this is too big, so then this is just a two-pointer problem where if it's too big, you move this down. If it's too small, you move this up. And then you can slowly close in on the solution. So that's one way to do it, and that would give you a O of... So to get the square or the square root is a logarithmic thing, and then the numbers you have to look for are square root of c. So it would be like square root of c log all of those numbers, right? So for each one of those numbers, you have to calculate a square. So I think it's something like this. And maybe, I think with a square root, you can actually like get rid of it, but it doesn't really matter. But that's essentially what you'd get for that one. Now the other one is we don't actually need to make all of these numbers beforehand. We can just keep trying numbers until a is too big, right? So let's say we're looking for like 105. We could just say like, okay, let's just try a equals 0, and then what's the value of b? And if b is an integer, then we return true. Then we'll try a equals 1. What's the value of b? If b is an integer, it will return true, and so on and so on and so on. So we could just say like, let's try all of these. And let's just show one example. So let's say we're on a value of 4 for a, and we're looking for this. And we can just keep going until we get to a number where the a squared is bigger than this. And then, like after that, there's nothing else that works. So here, for example, a is 4. So we could say like, okay, well, 4 squared plus b squared equals 105. So b squared equals 89. So then b is square root of 89, which would not be an integer, right? So then you just say like, okay, that's not valid, let's go to the next one, and so on. So that's basically what we're going to do. So we're going to try all combinations of A, which there's only 65,000, so that's going to be fine. And then for each one of those, we'll calculate what B is, and if it's a whole number, then we have a solution. So that's what we're going to go with, and then that will give us constant space. So I think that's probably the best way to do it. Maybe there's some other stuff, but those are the two I thought of. So we want to first figure out like what number to go to. So we can just say like int root or something equals, so square root returns a double, I believe, so we have to convert this to a root. So we can do square root of C. That will give us like our max value we can have. And then we can say like for int I equals 0, I is less than or equal to root. This will be the value for A, so in fact we can even write it A if we want to. Okay. So now we need to calculate the value for B. So B will be C minus A squared, and we want the square root of that. So we actually have to do math here as well. It's a math square root. Okay, so we want the square root of this, and we're actually going to store it as a double because we want to make sure that the square root of this is a number. So we're going to store it as a double first and then compare it to the int variation. So we'll say if B equals this converted to an int, and I believe the way doubles and ints work, so let's say we have a number like 3.82, and we'll just take off the decimal. So the only way these will be equal is if we have 3.00, which means it was an integer already. So if it was an integer already, it will be equal. Otherwise, this is not a solution. So if this is the case, return true. Otherwise, we just keep trying our next number until we run out of bounds. And if we tried everything, we'll just return false. So you don't actually, like, if you wanted a, like, if, let's say you had a question that they didn't let you use this built-in square root, you don't need to do it. You can do the solution that I said beforehand, where you just check all the numbers and then you square them ahead of time. So you have all your numbers and then you square them and then you have your 2 pointers. So that would work without using a built-in square root. Okay, so there we go. And as far as runtime, so we're looping through every number. That's the square root of C. So this is going to be of square root of C. And then for each one of those, we're calculating some other square root. All right, so we're calculating the square root of C minus A, which worst case is, you know, like square root of C again. So it's going to be like square root of C times, so to get the square root of a number is log of that number. So it's going to be like this. Square root of C times log C, I believe. Because to get a number squared, I think to multiply numbers is logarithmic, because I think you have to go through like all the bits. I did some multiplication stuff, but yeah, basically you have to go through all the bits of a number. And to get the square root, I don't remember exactly how to do that, but I think it's logarithmic as well. Like most of those are logarithmic, like power, square root, all those things. So that's going to be the time, and the space is O1. So yeah, not too hard of a problem. Bunch of different ways you can do it. Interesting whether the acceptance rate is low. But yeah, the basic idea is we can just get a square root, check if it's an actual whole number. A bunch of ways to do that as well. If it is, we have a solution. And just recognize that we can actually just brute force all of the possibilities for A, because this isn't very big. So it's fine. Yeah, and I don't know how you would not brute force all the possibilities for A. I mean, like I said, you can have the 2-pointer, but you're still, worst case, meeting in the middle, which is brute force. So yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.